consider in this part of the course. We are now going to talk about vectors and notation. Now, the vectors we are going to be talking about is the normal vector we know from our elementary mathematics, from our elementary physics. The normal vector we know, that's the vector we'll be talking about. Now, after that, we'll now move to field and field equations. We are now going to talk about the fields. We have basically different types of field, but our interest will be electromagnetic what field. Am I communicating? Thereafter, we'll now move to Maxwell's equation. Maxwell's equation. So the first thing you need to know is you need to know what is the Maxwell's equation. Then you now move to Maxwell's equation in integral form. Thereafter, we'll now talk about Maxwell's equation in differential form. And we'll now round up the first part of this course. So we can call this part one of this course. We'll now round it up with boundary condition. Boundary condition. So don't think it's very bulky. Forget the fact that they are just 5. You should have it in mind that it is very bulky. So if I'm you, I will quickly pick up a pen and paper, or better still, you do well to record the class so you can go through it maybe in subsequent time. Hope you are with me. Now, the first thing we are going to talk about, the first thing is vector algebra and notation. If you are not following, please do well to ask your questions. You will pay attention to that. The first thing we'll be considering is vector algebra and notation. This is the problem. This is now the first thing we are going to talk about is vector algebra and what notation. Now, the first thing you should be asking yourself is the vector we are going to be talking about. You get, and I told you that the vector we are going to be talking about is the normal vector that we know. What's the normal vector that we know? IJK, right? IJK. But we cannot talk about IJK without considering XYZ, right? Now, the first thing we are going to consider in this course is what we call the scalar field. Normally, when you want to consider vectors, you first talk about scalar quantities and what vector quantities, right? Now, after that topic in physics, you now start talking about what vector. Am I communicating? But remember, we are talking about electromagnetic field and wave. So what we'll be considering will be what scalar field and what vector field. So you can take down scalar field. Scalar field. We'll know what a scalar field is, and also know what a vector field is. So basically, if we are asked from the idea we had from our physics, when we are talking about scalar, we are talking about those fields that have what magnitude and no direction. Scalar. Scalar have what magnitude and no direction. So basically, this field here, we are basically talking about fields. These are fields that have magnitude, but they don't have what direction. While the vector, they are fields that have both magnitude and direction. So with this, we already know the difference between a scalar field and a vector field. So sometimes in your questions, these are very simple questions that they will be asking you in the exams, and you start fumbling up. Am I communicating? Now, in vector algebra, we consider 3 coordinates. I told you that you cannot talk about vector without talking about IJK. You cannot also talk about vector without considering what x, y, z. Now, when we are considering x, y, z, we are considering what we call coordinates. These are coordinates. Now, in this course, we have three coordinates that we consider. The first one is our Cartesian coordinates, the one we know. The Cartesian coordinates, which is characterized with x, y, z. This is the one we know. This is the one we normally use. Now we have another type of coordinate that is called the cylindrical coordinate. The cylindrical coordinate. Now, how do you identify a cylindrical coordinate? Now, how you identify a cylindrical coordinate is when you're now seeing arrow, file, and z. So you're now seeing arrow, file, and what? Z. You should know that you are referring to a cylindrical what? Coordinate. Now, the last type of coordinate in this course is what we call the spherical coordinate. Some people call it spherical, some people call it spherical. I don't know. We are in engineering, we are not in English language. So I will call it spherical coordinate. Spherical coordinate. Now, how do you identify this coordinate? This coordinate is characterized with what? Arrow, file, arrow, theta, and phi. So we have arrow, theta, and what? Phi. What's this sign? What's this symbol? Is it phi? Am I correct? Unmute your mind. It's phi, right? Okay. If I'm not correct, do well to correct me. We are all learning. Now, these are the coordinates which we have. We know that we have three coordinates: the cylindrical, the spherical, and the Cartesian. But our interest will just be on the Cartesian coordinates. When we now start talking about cylindrical coordinates, we'll now start getting confused, right? Because before you now start getting your cylindrical coordinates, you need to now consider centroid and the rest of them, which is not what we are looking for. But when we are now considering our Cartesian coordinates, then we know that we are now considering what? We are considering x, right? Y, and what? Z. Am I communicating? So basically, what we have here, we call this to be our Cartesian coordinates. Take note. Cartesian coordinate. Now, remember, we were talking about what? Vectors, right? And we said that we cannot talk about vectors without what? I, J, and K, right? So basically, here we have I here we have J, and on this side we have what? K. So in a case where we are not giving vector E, and they say represent vector E using the Cartesian coordinate, how do you go about it? Now, if you want to represent vector E using the Cartesian coordinates, what we simply do is, how do you represent this? We are going to take x, I, y, j, and z what? K. That's how to represent. Now, if you want to represent vector A, you simply have what? A multiplied by your x multiplied by your small plus A multiplied by y multiplied by j, right? Plus A multiplied by z multiplied by what? K. Are we together? So basically, this is how to represent your vector. This is how to represent the vector of this particular Cartesian plane. Are we together? Now, somebody will now ask me, what is now your AX? What is now this I? What is now your AY? What's now this J? And what's your AZ? What's now this K? Am I communicating? So basically, your AX here simply stands for what we call your magnitude. Magnitude. Your AI, where this and this, they are called what? Your magnitude. While your I here is basically your what? Your unit vector. And your unit vector stands as your what? Your direction. Am I communicating? Your unit vector stands as your direction. Okay. I think let me go to a new page. Now, I said you have, if you want to represent, let's say you have X, you have your Y, and you have your what? Your Z. If you don't understand, you ask me, come again. I like your question, come again. Now, here, this is I, here, this is what? J, and here, this is your K. Now, if you want to represent vector A, how do you represent it in vector form? Now, remember, when we are now considering vector, we said what are vectors? Vectors, they have what? Magnitude and direction. Am I communicating? Now, how do you now represent this? If you want to represent vector E, you are going to represent vector E with respect to the three coordinates. Sorry, with respect to the three alphabets we are seeing on our Cartesian plane. What are the alphabets we are considering? X, Y, and Z. So if we are representing A in this coordinate, it's going to be what? AX of what? I plus AY of what? I plus what? AZ of what? K. So basically, this is your vector E. You've simply represented your vector E using these alphabets on your Cartesian coordinates. So this is your vector form for vector E. Now, I now said AX here, your AX here simply stands as your magnitude. So your AX is representing your magnitude, your AY is representing your what? Your magnitude, and your AZ is also representing your what? Your magnitude. Now, these small values we are seeing here is what we call unit vector. They are called unit vector. And your unit vector shows you what? The direction of your field. So basically, your unit vector here stands as your what? Your direction. That is why we said when we are now considering vector, we are considering what? Magnitude and what? Direction. Now looking at our vector, is it having magnitude? Yes. Is it having direction? Yes. So that tells us that we have vector what? E. Had it been we have a scalar, had it been they said we should find a scalar. Scalar simply tells you that you are going to have what? AX plus what? AY plus what? AZ. This is the what? A scalar. Because what you are seeing is you are seeing magnitude without what? Direction. Am I communicating? Now, what if in a case where you're now asked to get your vector B? Vector B will simply be Bx of what? I plus what? By of j plus what? Bz of k. Am I communicating? So basically you have your magnitude and you also have your what? Your direction. And your direction simply stands as your what? Your unit vector. Take note. Now, when we are considering vector from our elementary physics, we do talk about magnitude, right? Magnitude. We are seeing, in fact, we are already seeing magnitude. How do we represent our magnitude? From our elementary physics, when we are talking about magnitude, not just physics, even in maths, you'll be hearing magnitude, in physics, you'll be hearing magnitude. When we are now talking about magnitude, what we use to represent magnitude is what? Absolute. So if you're asking, if they ask you to get the magnitude of vector A, what you simply do is you get the what? The absolute of what? Vector A. And getting the absolute of vector A, it will simply be what? Ax square plus what? Ay square plus what? Az square. Look at this very well. Are we seeing any direction here? No, we are not seeing any direction. But what are we now seeing? We are now seeing what? The magnitude only. So to get the magnitude of any vector, what you do is you take the square root of the vectors of the square of the what? Vectors given. Am I communicating? In fact, let's take an example. Let's say we have take down. Let's take an example. Let's say we were given vector E to be 7i plus 4j plus 3k, and we're given vector B to be 6i minus 5j minus what? 8k, right? And we're now asked to find A plus what? The magnitude of A plus what? B. How do we go about it? So the first thing you are going to do is to get the magnitude of vector A and you get the magnitude of vector B. After getting both magnitudes, what you do is you add both of them, you get your final answer. This is the exam question that is coming. This is an exam question. So if I'm you, I will better not joke with this part of it because it's looking simple, right? But it's easy to fail. Now, if we are now asked to get vector A, your vector A will simply be what? 7 square plus what? 4 square plus what? 3 square, right? So what you do is this is 49, right? Plus 16 plus what? 9. So what you do is you add everything here and that will give you, I think, 72. Is it 72? If you are with your calculator, do well to punch. I think it's 74. So we have 74 here. So what you do is you take the cube root of 74 and that will give you what? 8.602. Am I communicating? Okay. Now, if you have 8.602, always leave your value to be 3 dp. 3 dp, I mean 3 decimal places. 1, 2, and what? 3. Now, the next thing is to get vector B. Vector B will simply be what? The absolute of B. Now, getting the absolute of B, it will simply be what? 6 square plus, in brackets, this is minus 5. So you have minus 5 all square plus what? In bracket, minus 8. Minus 8 all square, right? So what happens there is you are taking the square of this. So if you are taking the square of this minus will basically cancel out. Basically, you are having minus 5 whole square is telling you that we have minus 5 times what? Minus what? 5. So what happens to this? Minus times what? Minus is what? Plus. That is why when we have this will simply give us 6 times 6 is 36, right? So if you do 5 times 5 is what? 25. Your minus will not be there again. So you have 25 because minus times minus is plus. Now the next one is minus 8 times what? Minus 8 is what? 64. So you have plus what? 64. And if you punch this in your calculator, what will you arrive at? I think 125. Yes. So if you punch that, you have 125 here. Now, if you have 125 here, you take the cube root of 125, and that will give you what? 11.180. 11.180. Now, you've succeeded in getting the vector A and what? Vector B. Magnitude for both vector. Now, what's the question telling you? The question is saying add both of these vector. So basically, to get A plus what? B, it will simply be what? 8.602 plus 11.180. And if you punch this with your calculator, you will simply arrive at what? Is it 19.782? I think 19.782. So we have 19.782. Do well to punch it with your calculator. So you will tell me the value as well. Now, we can see that we've succeeded in finding vector A, magnitude for vector A, and the magnitude for vector B, both of them added to what? Together. And we've gotten the answer to be what? 19.782. Assuming is a formula that we calculated for. You come here and you add Q, E, D, meaning you've proved it already. But this is not a formula, please. For the sake of our YouTube viewers, it's not a formula, it's a question that we just saw. Sorry. Now,